That's 5 here. And so there's supposed to be five frogs, and there will be 20, and there will be, yeah. I thought are we doing division or multiplication?
Division.
How?
Because we know what all the legs have, but we don't know how many legs. How many frogs. My marker doesn't look that good now.
I have another one.
Nah, it's the purple one. I'm just doing a this one. It's broken.
There are 5 frogs. No, there's 6 frogs. 24, 30, 35, 42, 48, 54.
It's 36.
Okay, so you guys think there's 5 frogs?
It's division.
It's what?
Division.
Really?
Yeah.
How do you know?
Because like we know how many legs are in total, but we don't know how many frogs.
Okay,
So I'm gonna put
back
that
together. 3, 2, 1. And markers clicked. Bodies forward. 0. Wow. I love all this work that I saw. And I love that when partners finished, some partners started talking with other partners to figure out what the deal was. So, hands down for just a second. I wanted to say that I noticed right away friends thought, ooh, we've been working on multiplication. So I'm just going to multiply 20 times 4. That's okay if you did that, because that's how you learn. But what's really important is that you think about the problem first, because some friends, when they really thought about it, they realized something. So before we share out our answers, because really I don't really care about the answer, I really care about what you did to solve it. So first I want to know, how is this problem different from the problems that we've been working on? What's different about it? Because we've been working on problems something like this, Alex. There were 3 cats. Each cat had 4 legs. How many legs did all the cats have? But this seemed different because we already knew how many legs there were. So Jorge, what do you think is different about this problem than the ones that we've been working on? Alex, eyes up.
That this is kind of like division.
What do you mean it's kind of like division?
Because 4 divided by 5 is 20.
Is 4 divided by 520? Okay, 4 times 5 is 20. Maybe say it the other way.
4, 5 times 4 equals 20.
Okay, but you said this is kind of like division, so how could I write it as division? Okay, Alex, this is a card change. I've already given you a reminder to have your head up. Your body needs to be facing forward. So how could we write it as division? You could tell us, or you could call in a friend.
It's like division because if you know how many legs there are altogether in 4 frogs, how many frogs are there gonna be?
Ooh, Jeffrey just told us something really important. We can usually tell if it's division if we already know the total. We already knew the total number of legs, but we didn't know how many frogs that made. So, scholars, today we're going to be working on understanding division as splitting into equal groups, and we're going to be talking about how division is the inverse of
Multiplication.
That's just a fancy word for the opposite. So we could write our fact family. Jorge already told us these equations. Who can tell us the division equations? What are the division equations? Kaylee?
The division equations are 4 divided by 20.
Bigger number first when we divide, just like subtraction.
20 divided by 4 equals 5.
Okay, and
4 divided,
bigger number first. Eyes up, Braulio. Same number first.
20.
Because that's our total, like Jeffrey said.
20 divided by 5 equals 4.
Excellent. There is our, please stop the clicking. There is our fact family with multiplication and division. Okay, now I'm curious to know how you guys solved this. If you multiplied, no big deal. Erase if you know you multiplied. And as friends are sharing their strategies, you can add them to your board to show division instead. Okay, so I saw some pretty cool strategies. I really loved Marisol's strategy. Marisol, I'm gonna hold up your board. And actually, Evan, can you hold this up nice and high so that everybody can see? You can go ahead and stand up here next to me. And Marisol, while Evan's holding it up for the class to see, can you explain what you did?
I drew 20 legs, and then every 4 legs I made a group for each frog, and there were 5 frogs.
Okay, so Marisol just drew out the 20 legs. There's all the 20 legs. And then she knew that every frog has 4 legs, so she started to circle 4 legs at a time. 1, 2, 3, 4. That's 1 frog. 1, 2, 3, 4. That's 2 frogs. 1, 2, 3, 4. That's 3 frogs. 1, 2, 3, 4. That's 4 frogs. 1, 2, 3, 4. That's 5 frogs. And then she knew, okay, well, if there's 20 legs, there must be 5 frogs. Great strategy. Thanks, Evan, for holding up. You can pass it back to Marisol. Hey, did anybody do something different than Marisol did? Marisol, call in a friend that would like to share what they did.
Me and Ashley did this. We counted.
Hey, Juan, can you come hold up her board while she shares? Thank you.
We counted by our 4s until we got to 20, and when we counted it got us to 5.
Okay, so why did you skip count by 4s?
Because there's 4. Because there's 4 legs and
4 legs on.
4 legs on 5 frogs.
Help her out. 4 legs on
Wow.
each frog. 4 legs on each frog, okay? So you counted by your 4s. So we did 4, 8, 12, 16. Why did you stop at 20?
Because in the pond it said there were 20 legs, and I thought if I got to 20, maybe I would find the answer.
Okay, so I see 4, 8, 12, 16, 20, but I don't see 5.
You count each number.
Oh, so this is 1 frog. 1 frog has 4 legs. 2 frogs have 8 legs. 3 frogs have 12 legs. 4 frogs have 16 legs. 5 frogs makes
20 legs.
20 legs, which Jeffrey said was the total. Ooh, thanks, Juan. Thanks, Kaylee. So I see a big difference between multiplication and division. When we are dividing, it's probably because we already know the total, and we have to figure out one of the parts. We already knew how many legs there were, but we didn't know how many frogs there were. So 20 legs divided by 4 legs on each frog makes how many frogs?
5.
5 frogs. Or, watch this. Oh, I can leave that 4 there. 20 frogs, 20 legs divided by how many frogs? I don't know. Makes 4 legs on each frog. And we figured it out. It was 5 frogs. Okay, so when I say go, I want you to go back. You can leave these things right here because we're going to use these also, but I want you to just grab your pencil. Go ahead. so quiet. When you get your paper, please put your name and date at the top.
I know.
And you can go ahead and erase your board. Name and date at the top of your paper. Okay, scholars, we're going to do 2 of these problems together, and then you're going to do the other 2 with your math partner. And these are just like the problem we already did. I asked you to keep your marker in case you like to work it out on your whiteboard first, and then once you've got it and you like how you showed your work, then you can transfer it over onto your paper. Okay? So let's first read the directions. Can you read them for us, please, nice and loud, Evan?
Solve each of the problems below you and show your solution.
Okay, so you want to pick a very clear way to show your solution. Maybe you show it like Kaylee did. Maybe you show it like Muddy Soul did. Do you think you should definitely write an equation?
No. Yeah.
Yes, okay, so please add to the directions, write an equation. We always want to be precise in math and have an equation with a label. So part of our directions are write an equation. So Paulina, you're going to need this workspace, so you need to put it near the directions. Okay, so I want to caution you. I want to give you a tip. Since I've taught, I told you guys for 8 years, I've seen this happen a lot of times with kids. It's a common problem. They see a story problem, like the ones we're about to read, and they read the story problem, and then they say, I think I'll subtract on this one. And they just pick a random operation to do. Because in life, there's only 4 operations. Addition, subtraction, multiplication, and division. So I've seen so many kids just read a problem and say, I think I'm going to add on that one. And then they just add the numbers. Or, today I think I'll multiply. And then they just multiply the numbers. And they're not even really thinking about what the story problem actually is. They're just picking randomly what they want to do. So it's really important that we don't do that. We want to really think about what the problem's asking and then decide. Jeffrey?
What about, how would they know if they're gonna add if they don't have the other number?
Exactly. So that's why it's so important that we don't just pick randomly, because we really need to think about what the problem is asking us. And you guys know I even sometimes like to close my eyes and visualize it, or I even like to act it out so that I know what's happening. Jorge?
It says division stories.
Oh yeah, well, and this is a big hint at the top. It says division stories, but sometimes you might get a whole page of story problems and it won't say division. So you might have to figure out what you need to do. Okay, so let's go ahead and read number 1. Eduardo's going to read it for us the first time. Okay, so I know that good mathematicians don't just read it once, they read it at least twice. I'm not really quite sure what this problem is asking, so let's all read it again. Ready and read. There are 28 desks in the classroom. The teacher puts them in groups of 4. How many groups of desks are in the classroom? Okay, so let's just visualize it for a second. If you like to close your eyes, you can. If you don't, that's fine. Let's just pretend that we actually have 28 desks and that the teacher is putting them into groups of 4, just like ours. So there's 28 desks. The teacher is putting